Good evening.
Good evening. Okay. So I will ask to the resource person, Sir Dhanith, sir. Sir? Yes, sir. Yes, sir. Good evening, sir. Good evening, sir. How are you, sir?
Good evening. Yeah, fine, sir. Fine, sir. Can you hear me now, sir?
Yes, sir. Sir. You are audible. You are audible, sir. No issue, sir.
Thanks.
Sir, can I take 2 minutes for giving introduction about you, sir?
Yes. You can take. Yes, sir.
Yes, sir. Yes, sir. Thank you, sir. Good evening to one and all present here. Heartily welcome to all eager participants. Your keen interest in 3 days international workshop under the title of Machine Learning Approaches for Engineering Application, presented by scholarsgate from July 16 to July 18, 2025, is truly inspiring. Welcome to all. We are most delighted to introduce our today resource person, Dr. P.R. Dhanith, sir. Dr. P.R. Dhanith, currently working as an assistant professor under the Department of Computer Science and Engineering at Vellore Institute of Technology, Chennai, Tamil Nadu. He was completed his doctoral degree from National Institute of Technology, Puducherry. He had more than 10 years of teaching and research experience and published several peer-reviewed research articles and book chapter under his credit. Dr. P.R. Dhanith also acted as a reviewer and editorial board member in profuse high-impact factor international journals. His research interests include natural language processing using deep learning. The scholars get really excited. My screen is visible, Rajesh?
No, not yet visible.
Okay, just 1 minute. Yeah, sorry for the inconvenience. The scholars get really excited to welcome our today resource person, Dr. P.R. Dhanith, sir, by virtual bouquet. Welcome, sir.
Thank you very much.
Yes, sir. Thank you so much, sir. Meanwhile, you can share your screen. I will give the basic instruction to the participants, sir.
Okay, sir. I will share.
Yes. Yeah, dear participant, thank you so much for your interest. Thank you so much for showing interest for this 3 days international workshop in machine learning. I hope we will try to fulfill your requirement, what you are expecting from us. So I want to give the basic instruction to you, because so your meeting recording, today meeting recording, it will be reached tomorrow afternoon, before afternoon 12 p.m. and your certificate and everything, it will be reached once the workshop is completed. So don't ask this type of the question during the session. Apart from that, do you have any queries at any time? So you can unmute yourself and discuss with the resource person. No problem for that. So we are trying to making these events the two-way interaction. I hope your support and cooperation is more appreciable. Thank you so much for choosing us, and I hope we will try to fulfill your requirement. So I am also eagerly waiting for learn new things from Dhanith, sir. Thank you so much, everyone, and enjoy the session. Yes, sir. Your screen is visible, sir. Please share your PPT, sir.
Yeah. Thank you very much, sir.
Yes, sir. Yes, sir. Your PPT is visible, sir.
1 minute, sir.
Yes.
Yes. Good morning, sir. Good evening, participants. Myself, Dr. Dhanith. I'm currently working as an assistant professor at Vellore Institute of Technology, Chennai campus. So in today's session, we are going to learn about machine learning concepts, applications, and real-world impact. So in today's session, we are going to learn about the basics of machine learning. In the next classes, we will learn about how to apply machine learning to various applications in the real world. This is the workflow logic today. This is the understanding today. So that's what we will try to incorporate. So I'm very eager to share my knowledge with you all, and hope this 3 days session will be interesting to you all, and it will be useful to you all. Along with me, you are going to do hands-on session with me. So please, be actively, do hands-on along with me also. So thank you for the. So first of all, we will learn about what is machine learning. So machine learning is the science of getting computers to learn without being explicitly programmed. So machine learning is not an explicit programming. So normally we will train the computers to do a task. That means that we will normally write programs to do computers to do a task. But machine learning is the science of getting computers to learn without being explicitly programmed. So we are not going to do any programming here. So we are going, with the help of machine learning, we are making the computers to learn without any programming. So machine learning enables the systems to learn from data and make predictions or decisions without being hard coded. So it's very simple. ML enables systems to learn from data. So it's very clear that there is no programming here. It is ML enables systems to learn from data. So the difference is we are not going to do any programming here. We are going to make the system understand from data. So that is the difference between machine learning and the normal programming. So normal programming, we will use to make the system work. But we are going to make the system work without explicitly programming with the help of a machine learning algorithm. So here, there is no need of any programming. So instead, machine learning algorithms learn from data. That is the point. So machine learning is a part of artificial intelligence, right? So it's a sub branch of artificial intelligence. So especially the main focus of machine learning is to learn from data, and from the learned data, it will be useful for make predictions. So it's very clear. We are going to, ML is a system which learns from data. From the learning, it will make predictions. So normally there are two types: ML versus traditional programming. Traditional programming, developer writes rules. That means that we will write programs to make the system work. The ML, it learns rules from data. That's the difference. So here, input plus rules we will get the output. But normally machine learning is different. Here, input plus output will give us the code, the different things. So input along with the rules to generate what output, that is a programming. But input and output, combined together to learn rules. This is the difference. So the traditional programming follows a fixed logic. So that means that it will uses a fixed logic. But this is adaptive logic. For example, calculator, 1 plus 2 is 3. So the addition is a fixed logic. Adaptive logic. So email spam. For example, the spam creators will create every day spam mails from different mail IDs, different logics, different ideas they will create. So whenever you are seeing the mail, you cannot predict whether the mail is spam or not. So for that, the traditional programming will not help you to. One day you will find that banking kind of spam. The next day you will get a rummy kind of spam. So banking is different from rummy. If you write code for banking, it will only filter out the banking spams. It will not filter out the rummy spams. So if you want to do that, you should make the machine learn from the previous experience or previous data. So that's the difference, right? So normally the traditional programming will work. We will write a program along with the input to generate output. So the main aim of programming is to generate output. But machine learning, the main aim is to generate the code or rules from the input and the output. So we have input, we have output. From the input and the output, we are going to learn, right? So real world examples of ML. Netflix recommendations. So nowadays, Netflix, Amazon, Flipkart, whatever may be the shopping websites, if you are opening it, we can able to get recommendations. So if you are purchasing a mobile, immediately Amazon is showing you mobile plus charging adapter plus wire plus the back case, cost is this. So recommendations. So it is recommending that the people who is buying the mobile phone will also buy what? This, the charger, charging pin, everything, they are buying. So that's why they are telling, right, the recommendations. Then second one is spam email prediction. So it will be helpful to us in predicting the spam emails. Third one is voice assistants. For example, we have Siri, we have Alexa. So whatever questions you are asking to them, it is responding to us with the help of ML models. Self-driving cars. So self-driving cars uses ML to detect objects, make driving decisions, and learn from them. So these are the various methods which will be helpful for you in doing the task. Types of machine learning. There are three types of machine learning. One is supervised learning, second one is unsupervised learning, and third one is reinforcement learning. So there are three types of ML algorithms. One is supervised learning, second one is unsupervised learning, third one is reinforcement learning, right? So there are three different learning algorithms, right? So first learning algorithm, supervised learning and unsupervised learning. What is the supervised learning? Supervised learning have the labeled data. Labeled data means what? For example, assume like this, the movie is good. What is its output? Positive, because it is a positive review. The movie is bad. It is a negative review. So the movie is good is the input, and its output is what? Positive. The movie is bad is the input. The output is the negative. So we have input as well as the output. We will call it supervised learning. So unsupervised means unlabeled data. What is unlabeled? We have the movie is good, but its label, whether it is a positive or negative, is not available. So only you have the input, you don't have the output. So that's why it is called as the unsupervised learning. Supervised learning means you have a labeled data. Unsupervised means unlabeled data. Labeled means what? We have input along with output. Unsupervised, we have input, but no output, right? So the goal of supervised learning is for predict outputs, predict outcomes. For example, whenever you are giving one input, the movie is super, then it should predict that it is a positive recommendation. But unsupervised learning, which is used to find the hidden patterns. How hidden patterns? For example, there are 10 apples, 5 mangoes, and 3 oranges. So 3 things are there. Now what I should do is I should group the 10 apples in one bag, 5 mangoes in one bag, and 3 oranges in one bag. By using what? Unsupervised learning. How it will do? It will find the hidden patterns. For example, mango will be in this shape. So if the shape of the particular object is like this, then it will be considered as a mango. If the shape of the apple will be something like this, so the shape of the the shape is like that, then it will be considered as the apple. So based on the shapes, based on the pattern, we should identify which belongs to which group. So this is, we will call it as what? Unsupervised. Output is known. That means that here in supervised learning, output is known because we know that the movie is good. Then what is its output? It's positive. But in unsupervised learning, output is unknown because you have 10 apples, 10 mangoes, 10 apples, 5 mangoes, 3 oranges. We don't know what is output. Based on the shape and structure and pattern, we are going to separate it, group it. So common techniques of supervised learning is including regression and classification. But the unsupervised learning, it's clustering and dimensionality reduction. Example, spam detection and house price prediction. In unsupervised learning, customer segmentation and topic modeling, right? So reinforcement learning is another technique apart from supervised and unsupervised. Learning from the environment. The agent interacts with the environment. For example, for a self-driving car, it has to the self-driving car has to learn from the environment. Sometimes flood will be there. So the road is damaged. The agent has to realize that the road is damaged. So immediately it has to stop the car. Otherwise, what will happen? It has to drive through the damaged area. So the reinforcement learning allows the agent to interact with the environment. So it takes actions, receives rewards or penalties. So normally the main aim of reinforcement learning is to learn optimal behavior to maximize long-term reward. Right? The key terms in reinforcement learning is agent. The agent is nothing but the learner or a decision maker. Right? Environment, where the agent works or where the agent acts. Reward, feedback from the environment. We'll call it as what? Reward. So three key terms: agent. Agent is a learner or the decision maker. Environment, where the agent acts. Reward, feedback from the environment. So examples include AlphaGo, robotics, game AI. So these three are the different examples, right? Core ML algorithms. So in ML, algorithms solve patterns from data and makes predictions or decisions. Here, a high-level overview of some widely used ones. One is linear regression. Second one is decision trees. Third one is K-means clustering. Then fourth one is the neural networks. So these four are widely, used ML algorithms. But there are many ML algorithms are available, available. But the most popular things are linear regression, decision trees, and K-means clustering and neural network. But a few more are there. We will discuss in the upcoming classes, right? So now we will start learn from this particular thing, right? So in today's session, we will give introduction about these things. So then in the next class, we will learn about the other algorithms, right? What is a linear regression? So linear regression is nothing but it predicts continuous values. It predicts a continuous values. For example, house price prediction. For example, based on the area, location, based on the nearby schools, shops, and all, the price value of the house will change, will vary, right? For example, if the house is in the center of the city, definitely the rent of the house will be high. At the same time, if the house is located in the in outer area, then the rent of the house will be lesser. So normally this is a scenario. Normally this is a scenario. So it's very important that the linear regression predicts the continuous values, right? So the linear regression predicts the continuous values, right? It is useful, it is useful for predicting a continuous value, not a discrete value. What is the difference between continuous value and discrete value? Continuous value means the rent of the house is 7,000, the rent of the house is 8,000, the rent of the house is maybe 7,500. So it will predict the continuous value. But what is the discrete value? Discrete is nothing but either positive or negative, either true or false. This we will call the decrease. So linear regression is used to predict a continuous value, right? Then decision trees. Decision tree, splits data into branches based on features, and it is easy to interpret. It is used for classification and regression. But the major working of decision trees is it splits data into branches based on what features, right? K means clustering. Clustering is an algorithm, right, which is used to group data into clusters based on the similarity. For example, the shape and structure of all the apples will be similar. So what K-means clustering will do? Based on the shape and structure, the apples are considered as what? Similar. So it will group us in, us together. Neural networks inspired by human brain, great for image, text, and speech tasks. Layers are interconnected neurons that learn complex patterns, right? We will learn more things. Now I will go for the hands-on actually, so that you can understand even better. So participants, you can do one thing. Whatever I am doing, you do along with me, right? All of you open your Google or Gmail account. If you have a Gmail account, please open the Gmail account, participants. If you have a Gmail account, please open the Google mail process. So then we will start our, hands-on. So you also do along with me so that you can able to learn the things in a better way, right? All of you process opened, Gmail account, so that if you can put it in the chat box and I can see it, I guess. So, Satish sir, I think so. Participants can message, right, in the chat box.
Yes, sir. Yes, sir. It can, sir.
They can. Yeah. So participants, once you open the account, please post. We have opened the Gmail account. Yeah, I think so. Most of you opened the Gmail account, right? So after open the Gmail account, we can go for the Google collab, right? So I think so we can go with this. Google collab. I will open, I will share the, I'll have to open this, link, so that you can able to do a code along with me, right? So I shared a link so that you can open the things like this. Just to click on this link or just to copy this link to your Chrome browser so that you can open it, right? Participants fast so that I can able to move ahead. So please reply faster. Once you open the Google Colab, it will ask like this, right? Once you open the Google Colab link, it will ask like this. One page will open like this. Just to click on new notebook. Just click on new notebook. A new notebook will be opened. A new notebook will be opened like this. Good, sir. So I think so. 2 people opened it. Others? Okay, bro. I'm assuming that everybody opened it so that yeah, very good process. So I think so. Most of you opened it. Very good process. Very good. So I'm assuming that all of you opened it. So I'm going to move ahead. So new notebook, um, so here, first of all, what we should do is, I'm going to a folder. Here, I'm going to create one Excel file. I'm going to create one Excel file, Microsoft Excel worksheet, and I'm going to name it as, movie. I'm going to name it as movie. So create an Excel file, right? So normal Excel file, right click, new, Microsoft Excel worksheet, Microsoft Excel worksheet. Just open this Microsoft Excel worksheet and just to save it and just click to open it. I think so everybody opened, this very good process. Many of you opened. I think so many people created or opened, Excel file, right? Excel file. So now what I should do is I'm going to create here reviews. I'm creating one header here, label. I'm creating two headers, right? One header is I'm going to create a header reviews, and other header is label, right? So two headers I am creating, right? So the one header is reviews. So the other header is label. So here I'm going to write the movie is good. So this is a positive review. So I'm going to make it as what? Positive. So here, this is my input and this is my output. So this is going to follow a supervised learning algorithm. So this is going to follow a supervised learning algorithm. What is a supervised learning algorithm? We are going to give input along with the output for what? For learning. For learning. I'm going to teach my machine with the input along with its what? Output. So that everybody can learn it better. So the movie is good. So it's positive. So the movie is bad. So it's negative, right? So the movie is marvelous. So it's positive. The movie is ugly. It's negative. The story telling is good. It's positive. The screenplay is not up to the mark. Negative. So now just save it. So this is the, just we are randomly giving, right? So we are randomly creating the data set, right? We're randomly creating the data set. So please, everybody follow this, randomly create a data set, right? So once after creating the data set, what you should do is go to the file at the top. Now select the option save as. Select the option save as. Select the option save as. So from here, in the Excel workbook, I have to select CSV, delimited. Just click on it. And movie, just to save it, right? Just to save it. So now, if you see here, there is a comma separated values file is what? Saved. Because normally than Excel file, we will use the comma separated values file as the input for machine learning algorithms, so that I'm just converting whatever may be the thing, I'm converting to what comma separated values or comma delimited, right? CSV files. So I assume that everybody did it. So we will continue ahead, and I will we will move ahead, right? So now what I'm going to do is, now first step, import pandas as. So this is the package used to read data from the comma separated values files, the CSV files. So always remember one thing, there is a package called pandas. This package is used to read CSV files, right? So next press enter, then from sklearn, dot feature underscore extraction dot text, because see here I'm using a text data. See, I'm using a text data. So I'm using a text data. I'm using a text data. See, so but no text data. I'm using a text data, but normally the text data cannot be understandable to the machines. So what we should do is, we should convert the this text data into numericals, so that a machine can able to understand it. So normally assume like this: machines understand only numericals. Machines cannot understand theories. So we should convert machine understandable things to human understandable things. Sorry, human understandable things to machine understandable things. So what we are going to do is, we are going to convert a text data into numerical data. So what I'm going to do is, I'm going to from sklearn dot feature extraction dot text, I import count vectorizer. So count vectorizer, right? So I'm going to by using a method or by using a function called count vectorizer, I'm going to convert the text data into a numerical data, right? Then next thing, from sklearn dot model, from sklearn dot model underscore selection, we are going to split our data into training data as well as the testing data. So import train underscore test underscore train underscore test underscore split. Now what I am going to do is, from sklearn dot tree import decision tree classifier, decision tree classifier. So I'm going to use a decision tree classifier, right? Decision tree classifier. So the decision tree classifier I'm going to use for prediction, right? Then for computing the the performance of the ML algorithm, I'm going to use the accuracy score. I'm going to use the accuracy score, right? So now you can execute it. If it executes without any error, then the code is fine, right? So try to execute it. If it's working fine, then it's fine. Yeah, it's a tick mark came. Everything is fine. So process, I will just copy the code and share with you. You can just use it for your, yeah. So process, just use this code, and I think so. Most of you done it. Very good process. So please, use it. And once it is executed, just let me know it's done or not, so that we can continue process. I'm waiting for your messages fast. If any error comes, use the code that I shared with you. Process, please reply process so that I can continue. I'm waiting for your message because it's a step-by-step procedure so that I want everyone completed. So that's it. I'm waiting. A very good process. Very good. Very good. Yeah, very good process. Very good. Very good. So I think so. Most of you are completed. So I'm just move ahead. So next step, we'll move ahead. So carefully listen, process. So next, what I'm going to do is I'm going to create a new code. This new code I'm creating. So here I'm going to first read the data. So D is equal to, I'm going to read the data. So I already told you that what is my data? The data, this is my data, right? So this is my data. So I have to read the data. So how to read the data? I already told you that we are going to read by using pandas. So here pandas I renamed as what? PD. So PD dot read underscore CSV. Read underscore CSV of, right? Open bracket, close bracket. Yes. But now listen one thing. Before proceeding this, I'm working with the Google Colab so that it cannot able to learn the data whatever in your system. So what I'm going to do is I'm going to, the left hand side, can you see there is a folder like symbol? There is one folder like symbol. Just click it. And what I'm going to do is the CSV file, this comma separated values file, just drag and I pasted here. Yeah. So my data is ready now here. Now what I'm going to do is along with this, there is a 3 dots. Can you see here? Just click on it. There is an option called copy path. There is an option called copy path. Just copy path and paste it. And paste it. Then execute it. Yes. So now it's done. So now create one more code, right? So it's read the data. Now what I should do is, now see here, I got two options. One is reviews, another one is the label. So I have to separately read it. For that, what I am going to do is text is equal to T data of within a single quotes reviews. Then label, this is the input, right? So I already told you This reviews is the input, label is the output. So output I should read separately. So labels is equal to D of label. So yes, so the input is red. Now execute this also. So execute this also. It is executed fine. Now one more code I'm creating here. Convert the text into numericals. So how to convert the text into numericals? V is equal to, I already told you that the function count vectorizer I'm going to use. Count vectorizer, open bracket, close bracket. Now here, read the input. X is equal to, let's use the variable, any variable, v dot fit underscore transform of text, right? So this reviews or this text is converted to what? Numericals. Now execute it. Yeah, it's also executed. Fine. Now what the next step is, I have to start to train it, right? Start to train it. How to train it? For training, I'm going to use the decision tree classifier. DT is equal to, what is the classifier name here? Decision tree classifier. So copy it, paste it, open bracket. So decision tree classifier, I'm going to use. Now, what I'm going to do is, this DT dot fit of X. X is the numerical of text, comma, labels. Labels. Now, start execute it. Yeah, execution is done. Decision tree classifier is worked perfectly. Now what I'm going to do is, my model is ready and the model is DT now. With the help of DT, I'm going to predict. So, output Y is equal to, right, DT dot predict of yes, what we can do is, listen, I'm have one text, T is equal to the movie good. This is a text, right? Now what I should do is, I should find out whether the movie is good or not. So what I'm going to do is, I'm going to convert this one, text vector is equal to, first convert this text to numerical. So v dot transform of, right? So I got a vector now. Now what I should do is, I should predict. So y is equal to dt dot predict of TV. So finally print the value of y. Now see, it is giving me the answer as positive. Just a model is giving me the answer. The movie is bad. If I'm giving the answer like this, it's negative. So I just trained what is the input, what is its output. Now if I ask the machine will teach me or give me the answer, based on my input, right? So this is the logic working behind the, logic working behind the various machine learning algorithms, right? So I think so. Most of you completed it. You need code or have you completed the process? Just share your point of view. Have you completed the code along with me, or can I share the code? Completed or not? You need code or you already completed? Okay, see process, see and complete process. First, I will give 5 minutes of time. complete the work faster. The code process complete fast. I will give 5 minutes of time. If you have any doubts, please post it in chat box. Share the code. Okay, I will share the code with you, process.
ज्यादा नहीं चलाना
I have shared
फेंकना
the
नहीं है
code with
उसको,
you,
फिर
process.
खराब हो
Please
जाता है,
use
ये
it.
खराब हो गया इसी वजह से।
Please process fast. Process, now can you able to complete? Process, have you completed process? Once you completed, just post your messages. If any error you are getting, please ask. I will please post it in the chat box.
I'm getting an error of, I think I'm making some mistake in assigning the path.
Yes, actually, no, that the CSV file path is missing.
Sir,
It means that, no, listen here, ma'am, in the code, you have just to, there is in the left hand side, you have a file folder like symbol, right? Files, there is a symbol like, right like this, right, ma'am? Just to click on it. Here, what you should do is, I will share you, just if you click on this, it will open like this. Here, you can just drag your CSV file and drag your CSV file and and paste in this location, or just click on this upload symbol where where your this CSV file. Just click on it. It will automatically save here. Now, there near the file, you have three dots. Copy path and paste it here. Paste it here. Then it will work out. Yeah.
okay, sir.
Process, do fast process. All right, so 5 more minutes, complete fast.
Done, sir.
Thank you, ma'am. Thank you. Other process, have you completed? CSV file, I can try process. I think so. We can't share CSV file here. Like, no, professor. Actually, I can't share CSV file. I guess. Yeah. CSV file, I think so. I can't share process because it is not allowing me to share. I guess I can't share. I guess. I will share later. Now I can't share. I guess. I will ask the coordinator to share the. Yes, process. So I think so I'm assuming that you have completed most of you. So I think so shall we move ahead, right? Process? Other process? Shall we move ahead or any other questions or anything you have? I think so we'll move ahead, right? Process? Yes, process. So there are some few problems with overfitting and underfitting. So overfitting and underfitting in machine learning is overfitting means model memorizes the training data, poor on new data. That means that uh, if model it can able to uh, work well on the training data, but if a new data is given, the model will struggle. For example, I will show you this example just we completed, right? So here the movie is bad, movie is good and all we trained. The movie is excellent. I'm giving this word and executing. See, it is predicting negative. Can you understand? Movie is excellent, but the training data, I didn't use the word excellent. So it's a new data. So this problem we will call it as what? We will call it as overfitting. So overfitting means for the for good bad we already trained. It perfectly predicts, but excellent a new word we used. It failed. It failed. This is the biggest issue. Overfitting problem. This problem we will call it as a overfitting problem. I think so you can understand, right, process? So if you are going with a new data that is not trained, then the model will fail. That kind of models we will call it as overfitting. Underfitting. Model is too simple, misses patterns. Underfitting. Enough training data. This see, we have already trained with only 6 to 7 data. It's not sufficient. You need a huge amount of data to do that. So we are missing with the huge amount of data, right? So this is also another problem, right? So this is another big problem. So these two are overfitting versus underfitting. Then training versus the testing data. So training set used to teach the model. Testing set used to evaluate the model. So training set used to teach the model. Test set used to evaluate how much the model is generalized. So that's all about the testing data versus the training data, right? So training data is used to train the model. Testing data is used to evaluate the linear regression, right? So linear regression, I already taught you what is a linear regression. Linear regression is a model, it's a regression model which is used to work on the continuous data, not on the not on the we will call it as not on the testing data, sorry, not on the discrete data. So just now we worked on an example with the discrete data. We have only two outputs. One is positive or negative. But here we have variety of data, so that the continuous values, so that model can able to generalize it well. So I will come up with an example now, right? So you can easily able to understand it. So we will go with, we can go with again collab, open new file, new notebook in Drive. So here I'm going to import NumPy package as NP. There is a package called NumPy. This package is used to, this package is used to generate matrices. It is used to generate matrices because here I am going to generate some dummy data, right? Synthetic data. So then import, then from sklearn dot linear underscore model import linear regression. So import linear regression. So then I'm going to use random data. I'm going to create a random data for training. So for that, np dot random dot seed. np dot random dot seed of 42. Random data, right? We are going to generate a random data, right? So here I'm going to create x is equal to 2 into, I'm just randomly creating some data. So np dot random dot rand of 100.1. Then y is equal to 4 plus 3 into x plus np dot rand of 100 comma. So 100 data I am going to create. Then what I am going to do is, after creating the input as well as the output, I am going to use a logistic regression. So m is equal to linear regression. The copy the same function, open bracket, close bracket. Now what I'm going to do is I'm going to start training it. So to train it, m dot fit of your inputs x comma y. So now the model is ready. I am just going to execute it. So now I am going to open the code. I'm going to find the output. So y is equal to m dot predict of the input x. As I am already creating a numerical model, numerical data, so I don't want to convert into numericals. Already it's a numerical data. Now print of y. Sorry, it's y, right? See, this is a random data generated. So the answer almost 100 data. So it's predicted, right? Correctly, it's predicted. So if you want to check what is the value of print of y here, if we can check it, a print of y. See the same values, right? Same values. The same values, it's predicted properly, right? So this is the way we should use, we should go for the logistic regression. So this is one way. Suppose if we have numerical data with a lot of, I will show off how to use, it with, how to use it with a data set. I will show you. Now, just now I shown you, yes. So I have shared the code with you. You can use it, right? Yes, I think so. I have shared the code with you. You can just use the code for execution, right? So I have shared the code with you. 1 minute process. I will join. So you just complete the code process and just share me the thing here.
Dhanith sir.
Yes, sir. Yes, sir. So
Any sir?
no problem from my side. People are working on it, so that's why I'm just.
Okay, sir. Okay, sir. Thank you, sir.
It's not 2 into NP processor, not 2 NP, 2 into NP, 2 just star NP processor. Let's change it. So process, I'm going to show off one more logic now based on the logistic regression, right? Yeah. Yeah, I can share my screen, I guess. I can share. Process, have you completed the process? All others? Yes, process. I will, I will show off. Listen, process. I have created one data set. I have downloaded one data set. Yeah. So I will just extract here. Yeah, I have one data set, electricity cost data set. See this. There is a site area of 1,300 square feet. There is a mixed use. Water, consumption is 2519. Recycling rate, utilization rate, air quality, issue rate, residential cost. Now they given the electricity cost. Now what I should do is, based on these functionalities, I should find out the electricity cost. I should find out the electricity cost, right? So that is the task. So what I'm going to do is, I'm going to, based on all these factors, I'm going to predict the electricity cost, right? By using the linear regression, because linear regression can able to predict any kind of continuous values. So here the values are differs. Values may be anything, but machine learning algorithms normally predict yes or no only. But here we are going to predict what? The numerical values based on the other factors. So for that we should write a code. I'm going to open a new notebook in Drive, right? So here in this drive, I'm going to open this folder like symbol. So here I'm going to upload this data, right? I'm going to upload this data. I think so. I can upload data from the downloads. So from the downloads, I'm going to upload the electricity data here, right? So this electricity data I'm going to upload here, right? I think so. It will take some time because. Let it be. So let it have download. Now what I'm going to do is, I'm going to start the coding here, coding process here from sklearn dot linear underscore model import linear regression. So from sklearn.linear model, import linear regression. So I'm going to perform a linear regression on it. Then from we'll go for the linear regression model. Then what I'm going to do is I'm going to create the input and the output. So what are the input and output? So input x is equal to there is a package import pandas as PD. So I'm going to use a package called pandas as PD. Now what I'm going to do is I'm going to read the data. So df is equal to PD dot read underscore CSV of codes. Now here data I should upload data I have uploaded. So it's not uploading. 1 minute process. Reload this page. Upload. Yeah, data is uploaded. Now I'm copy the path and paste it here, right? So now I have uploaded the data. Now here I'm going to split the data. It's read, right? So read underscore CSV. X is equal to df dot drop. Why? What I'm going to do is, listen here, this is my output. This is my output, right? So the output I have to drop and add as a what? Add as a output, right? So add as an output. So df dot drop off within a single quotes. What I'm going to do? I'm just going to copy this one and paste it here, or electricity cost, comma access is equal to 1. It's open bracket. It's open bracket, close bracket. It's open bracket and close bracket, right? Then y is equal to df of this one, this electricity cost. df of the electricity cost, right? So now we can go for we can go for like this, right? So we can split this data, or we can go like this. We can go for model M is equal to linear regression model. So linear regression model I'm using open bracket close bracket. Now I'm just going to train it. So m dot fit of means it will do the training. So training of what? X, training of x comma y. So just execute it. Yeah, there is one more thing. Drop now. Drop of electricity cost. Yeah. Comma. Structure type. So it's executed. Now what I'm going to do is I'm going for training. So for prediction, what I'm going to do is X prediction is equal to I'm going to use this input, right? So use this input, any input I can use. So I'm going to use this input. So I'm going to use 1360 comma 1360 comma 2519. So 2519 comma then 6952. So 69 comma 52 comma then 188 comma 188 comma 1 comma 72. So 72. So this is the input. Now we can go for prediction. How we can go for prediction? Y is equal to m dot predict of xt. So print of y. Now execute it. Yeah, so I got the answer 1672. So what is the electricity cost? Almost it is predicted a mere 1420 is the right answer, but it is predicting 1672. So this is the answer it predicted. So it depends. So the model predicted this is the answer. So now I think so you can understand what is the use of the linear regression, right? So the linear regression will work like this, right? Yes, process. Now, if you have any doubts, please post to me. If you need the code, I will share it with you so that you can able to continue, complete it, right? So I will share the code with you, process. I have shared the code with you, process. Dataset link, I will share it with you, process. 1 minute. I will share the dataset link with you so that you can download the dataset. I have downloaded the dataset from Kevin. I will share the dataset code link with you so that you can download the dataset also from your machine, right? Yeah. So this is the dataset link also. By using your Google account, you can log in this also. So you can download the dataset and you can complete process. Any doubt, please post to me. I will help you with this. Any doubts, please post to me, process. Yes, process. You can ask a question. Yes, Neelam ma'am, you can ask your question. Please unmute and ask.
Hello, sir. Actually, I have a
Yes, ma'am.
question
Yes.
regarding the overfitting and underfitting. You talked about that. How to handle it?
Ma'am, actually, normally the problem will be solved by with the help of a huge amount of data, right? First of all, the underfitting problem can be solved by using a sufficient data, right? If you have sufficient data, you can solve the problem very easily, right? An underfitting problem will not happen. It will have enough amount of data. It will be, but overfitting problem, the major problem is um, the lack of capability of the learning algorithms. So that nowadays many top-end models introduced. For example, even now we are in the era of transformers. So even ChatGPT designed by using transformers, right? So now we are in this era. So when the model becomes advanced and when the model becomes more and more competitive, then these problems will be sorted out. So my suggestion is that whenever you are going for a better neural models, that problem will be handled in a better way. But the basic solution for both underfitting and overfitting is enough amount of data. If you have huge volume of data, then the problem will be solved. But the major issue is overfitting. Whatever data you have, the data can be answered by the machine learning algorithm. But out of box question is asked, this problem will be tackled. So that in nowadays there is an algorithm called weakly supervised learning algorithms were introduced nowadays. What is weakly supervised learning is half data with labels, half data without labels, so that model can able to generalize the unlabeled data also, can handle the unlabeled data also. So such learning algorithms will be helpful to sort out the sort out the problem of overfitting, right, ma'am?
Okay, one more question is how to know there is overfitting or underfitting? Like you talked about low bias
Yeah, if
and
your
high variance.
model, that's what I just showed. No, I have shown just one example, right? This, yeah, I think so. This question, right? See, I have trained the model. The movie is good. The movie is bad, but I didn't train with the word excellent. See, once I give the model, the movie is excellent. Show me next plus the answer. But actually, it is positive.
Yeah.
So I know that the model is overfit, right?
So how do you
And
know this is overfitting or underfitting?
yes, assume like this. Here, whatever data I have trained, the model is working, answering it properly. For example, I'm giving the answer as good, right? It is giving me positive because I trained the word. I'm giving the word as bad, it is giving me negative. But when I'm giving the word excellent, it is giving me the wrong answer. Why? Because my data set has what? My data set has the word good, my data set has the word bad, but my data set does not have the word what? Excellent. So it clearly shows that the model is overfitting. How to find out that the model is underfitting is why the problem happened. The problem happened because of the data set size is what? Less. So enough amount of data is not fed to what? The machine learning algorithm, right? Because normally it needs at least 1 lakh data, but I'm trained with only 6 data. So definitely my model is what? Knowledge wise, my model is very less, right? For exam, 4 chapters for exam, but I learned only 2 topics, 2 chapters. Can I able to get 100 marks? No. So that's the problem. So I have to train with the enough data, but the data set is very less. So it can cause what? Underfitting also, right? Can you understand now? This is the
Okay.
logic.
Thank you.
Yes. Any other queries, browsers? Or have you completed whatever I have taught to you? Please push.
Dhanith sir?
Yes, yes.
Yeah, whether your part is over, sir?
My part is over, sir. If the participants has question, please.
Okay. Thank you, sir. Dear participant, do you have any queries? Kindly use this time. So otherwise, we wind up the today's session. We can move on tomorrow. In one line of code, there is something written access. Sir, one question is coming from chat box, sir.
Yeah. Access is equal to 1 means assume like this. Sometimes the model can be viewed. Yes. Assume like this. So sometimes the model should be viewed from multiple ends, right? So for example, in sklearn pandas like pandas and numpy package, normally it will perform operations in the along with the columns, right? Normally it will perform operations along with the columns, but normally if we set axis as 1, right? Actually we are going to perform actions column wise. For example, the data assume like this: the site area, the water consumption, recycling, utilization, air quality issue, column wise. So I have to take the values in a column wise for the better prediction. That's why I'm setting the value as what? Axis as 1, right, browser? Any doubt, browser?
Yeah. Any other question from participant side? Okay, sir. Okay. Thank you so much, Devak sir, for your valuable question. Any other question from participant side, so we can continue the session. So otherwise, we will wind up the session today. Okay. There is no question from the participant side, sir.
Okay.
Yes, sir.
So I think so we can continue the session from tomorrow, right, sir?
Yes, sir. Sir, thank you so much for invitation and take over the wonderful session, sir. So thank you so much. We will start tomorrow's session